Good morning, mechanized agriculture class. Hopefully everybody is doing well. We had class yesterday where we took a little quiz about cement and cement pouring. We also laid out our project, at least the start of our project, where we're going to build a wash rack, which will incorporate some plumbing because obviously we have to put water to it. We're going to build some forms, so we're going to do some woodwork around the edges. We're also going to put a pipe railing around it. So hopefully everybody remembers that project layout, and we're having material to get to work on it fairly soon. I just wanted to continue talking a little bit about cement and some of the things that you need to know before you start mixing your own cement. So, how do we mix cement? Well, the rule of thumb is, and this is what Grandpa probably taught you, and you just have to put it in your memory bank so you remember it, is we are going to go 1 part cement, 3 parts sand, and 3 parts rock. I like a rock that's like a 3/4 minus. Some people might want their rock a touch smaller than that. But if you go larger, it makes it a real challenge for you to work with that cement. So a 3/4 minus rock is pretty nice. But it's 1 part, 3 parts, 3 parts. That's the old rule of thumb. And if you're using that old hand mixer that goes round and around, you're going to throw in a shovelful of cement, 3 shovelfuls of sand, 3 shovelfuls of rock, as you are adding some water. This is the rule of thumb. It's really easy to do. If you're doing a large pour, I don't recommend doing it this way, as you can only mix fairly small amounts at a time in those hand mixers. Water is hugely important for the strength and the durability of your cement. Obviously, too much water, if it's runny, soupy kind of a mix, it's going to weaken that mix because all of that water has to evaporate out, and it will make the edges of your cement chip very quickly and early in the lifetime of that cement. Too little water, and you almost can't work with it. So it makes it a real challenge to get it smooth and do a nice job with your finish work. So I like to order my cement, especially if I'm pouring more than a yard. We did some calculations yesterday. Everybody remembers how to calculate how much cement that you need. Length times width times depth. And then we're going to divide that by, you remember, 27. And that'll get us our cubic yards. And so that'll tell us how many yards we need to order. So these are a few questions if you're going to order your cement and not want to go to all the work of mixing it yourself. They're going to ask you how many sacks in the mix. They're talking about cement sacks. When we are looking at this, I like a 6-sack mix. It will give us somewhere around 3,500 psi, somewhere in that ballpark, which is usually plenty, even if you're going to drive equipment and things on your pour. So depending on how much strength you need that cement to have, you can adjust that hardening factor of the cement. They might ask you whether you want fiberglass or not. Fiberglass is a cool thing, and it actually helps that cement bind together. It will make it slightly stronger. So you have to decide. It's obviously an added cost, so you need to figure out whether you like it. They might ask you whether you want hot or cold water. Well, what's the difference? So if I needed the cement to set up quicker, I'm going to have them use hot water. That means that the cement will set up a lot quicker, which means I better have a crew on it to get it finished, laid down and finished quickly, or I'm going to lose my window of finishing time for that cement. Cold water just sets up a little slower, so sometimes if I want it to set up a touch slower, just use regular cold water. There's very few instances where I would ever order hot water to make it set up quicker, just because usually it's me and the family finishing the cement, and we are just not fast enough to handle it if I have it set up too quickly. And then the last question they're going to ask you is how many yards. I suggest that you estimate at least a quarter yard over whatever you think you're going to need. This is because there is no way you're not going to spill some. You're going to have some that spilled over the edges as you screed it, which means you're first flattening with your board. You're going to pull some over the edges. There is almost no chance that you're going to waste zero cement when you're pouring out of a cement truck. Now remember, most cement companies are going to give you a quarter over anyway. So if you order 2 yards, they're probably going to mix 2 1/4 in the truck because they don't want to short you. Still, order a quarter over so that you have a safe amount, because there is nothing worse than to get to the bottom of the cement truck where there's no more cement and you still have a open or bare spot in your form, and you have to send the truck back and then remix and come back again. You're going to pay 2 delivery fees, plus your cement is going to be half set up by the time the truck gets back. Just not a good idea. Make sure you order enough. So run through your equation, calculate it out, and then plan for at least a quarter yard over. Alright, on cement mixing, if you can see this slide, 3,000 psi cement is going to run about 515 pounds of cement, 1,500 pounds of sand, 1,600 pounds of gravel, with 34 gallons of water. That is just short of a 6-sack mix. If we look at our 4,000 psi cement, it's 611 pounds of cement and 1,450 pounds of sand, 1,600 pounds of gravel, and 34 gallons of water. Most of the sacks are about 94 pounds. So that is going to put you with a 6-sack mix right in the middle between those two in terms of the amount of cement. And that's my favorite. In certain situations, you might want to adjust that. Definitely your call depending on what you're pouring. But for our wash rack and what we're doing, 3,500 psi cement is more than enough, since we're only going to have horses and maybe some cattle and things like that on our cement pour when we're done. Rebar. We talked a little bit about rebar in class yesterday, and we talked about whether we needed it or not. I think it's extremely important. I expressed that in class. I want us to make sure that we think about it. Some of the real important things about rebar are that it makes your cement stronger. You're going to have less cracking and it will last longer. I recommend that we put rebar in a 2 by 2 foot square. Number 3 rebar is the best. That's probably just a touch over a 3/8 inch rebar. Some people like to put wire in it. They'll use the wire panels, they'll cut them, and they'll throw them in the rebar form. That will work, but it is not as strong as rebar. Plus, it will disintegrate, rust quicker than your rebar. So your rebar is the best route, and rebar is really cheap. So it doesn't take much. But we're going to lay it out. We're doing them in 2 by 2 squares and make sure we get that in our pour. Is it worth it, time and money? The money is pretty reasonable to buy rebar. It does take some time because you got to cut the rebar, you got to wire it all together in the squares and lay it out like that. So it does take a little extra time, but for me, it's worth it. It almost doubles the life of the cement, so that cement will stay stronger longer, and it will control the cracking. There is almost no way that you're going to pour cement and not have a crack. It just cracks. That's what cement does. That's because it shrinks, right? And they figure about for every 100 feet of cement you pour, it's going to shrink almost 3/4 of an inch, which means I need to be thinking about that shrinkage. And with the rebar, it will help hold it together, and it will stop cracks as they go, so you don't get as big and as uneven of cracks in your cement. But you have to make sure that you get the rebar in the middle of your cement. So we're going to lay the rebar out on the ground in our forms. We're going to get it all wired together 2 foot by 2 foot. But when we start pouring cement, as we go, we're going to lift the rebar and shake it up into the middle of the cement. Obviously, we can't have it at the very top of the cement or it's going to be showing, and that will cause some flaking and weakness in our cement. And if it's laying on the ground, it does us no good. We wasted our time and money. So it's very important we grab that as we go. We just shake it a little bit, and it will lift and rise right into the middle of our cement pour. And then our cement will be strong and will last for years. All right, I got a little assignment for you. With every one of these fancy lectures, you're going to get some sort of assignment that you need to do. I would like you to go out and look at some different cement pours, old, new, whatever you can get access to, and you're going to take a couple pictures. I would like 2 different pours where you take some pictures of it. In your pictures, I want you to look at the cracking, how smooth it is, what kind of finish they have on it, whether they have a broom finish or if it's stamped concrete. Make sure that you take a look at it and see how that's all done. And I want you to check out how much cracking is in that cement. Is the crack just a hairline crack? Is it a big crack? Is the crack in it and then the cement is uneven? Make some notes about that and take a few pictures. I also want you to take a close look at how many feet there are between each expansion joint. That is really important because if we put expansion joints in, it will stop the cracks. The more often we put expansion joints in, one, that concrete shrinks, and like I said, 3/4 of an inch for 100 feet. So if I put expansion joints in different places, it will limit the amount that's going to shrink away from our expansion joint. So if I have a 2-foot slab, the shrinkage on it is almost unnoticeable, where a 100-foot slab is 3/4 of an inch. So think about that and look at how many expansion joints they have in it. And the expansion joints are just that handmade crack that's put in it on purpose, where they break it, like in a sidewalk where you see the cracks that are put in intentionally. Those are expansion joints that help control the cracking and that in that. So good luck, have fun, and hopefully we'll be ready to roll on our wash rack, which we're going to start laying out and putting forms to it and squaring it up on Friday.